A language model has never read a single one of your documents. Not your wiki, not your contracts, not last quarter's numbers, not one word. Retrieval augmented generation is how you hand those documents over at answer time without retraining anything and without touching a single weight. Before I criticize any of this, let's be fair. A frontier model on its own is genuinely astonishing, and most of what it tells you is simply correct. It has read an enormous slice of the public internet, general knowledge, code, history, science. For all of that, retrieval adds precisely nothing. It reasons across steps, holds a long thread, writes more cleanly than most of us. So the problem is not intelligence. The problem is much narrower. Here's the narrow problem, and watch the meter in the corner while I say it. Everything this model knows was frozen at a single moment in time. Ask about anything after that moment, and it doesn't say, I don't know. It guesses fluently in exactly the same confident voice it uses for the truth. And your internal documents were never inside the building at all. Private wikis, contracts, support tickets, pricing, the model has never seen a word of it. So here's the whole idea, and it really is this simple. Don't teach the model your data. Go and look the answer up first, then paste the relevant passages straight into the prompt and tell the model to answer using only those. Retrieval first, generation second, always in that order. The pipeline has three acts, and almost every mistake I've had to debug came from confusing which act the problem actually belonged to. Act 1 happens offline once. Load your documents, cut them into chunks, turn every chunk into a vector, and store all of it in an index. Act 2 happens per question in milliseconds. Embed the question, search for the nearest chunks, then reorder them by how useful they genuinely are. Act 3 is the part everyone thinks is the whole thing. Assemble the winning chunks into a prompt and let the model write with citations attached. Act 1, chunking. It's the least glamorous stage in the entire pipeline, and it quietly decides whether everything downstream works or fails. Chunk too big and one vector becomes a blurry average of four unrelated ideas, so it matches every question a little and none of them well. Chunk too small and you retrieve a sentence with no context around it. Start near 400 tokens with light overlap and split on headings rather than blindly on characters. Embeddings next. Each chunk goes through a small model that turns text into the long list of numbers, a single point in a few hundred dimensions. The whole trick is that the geometry carries, meaning text about billing lands near other text about billing even when the two share no words at all. That's why retrieval survives paraphrase. Someone asks how we charge a customer, and you surface the chunk that says invoice because those two live close together. Act 2, retrieval. At query time, you embed the question with the very same model, then ask the vector store for its nearest neighbors. It never compares against every chunk. An approximate index checks a tiny fraction of them and returns the top handful in single digit milliseconds. But pure vector search fumbles exact strings, part numbers, error codes, source names. So run old fashioned keyword search alongside it and merge the two lists. Now, the belief I would most like to kill, retrieving more chunks, does not give you a better answer. Very often, it gives you a worse one. Attention spreads unevenly across a long prompt. Bury the correct passage in the middle of 20 others, and the model will skim straight past it. So, retrieve wide, maybe 50 candidates, then run a cross encoder that reads question and chunk together and keeps only the best 5 precision beats volume. Act 3, you assemble a prompt, a short instruction, the surviving chunks each tagged with a source ID and the user's question sitting at the bottom. The instruction is the load bearing part. Answer only from the passages above. If the answer isn't in them, say so plainly instead of improvising something. And demand a source ID on every claim. That single line pushes the meter in the corner near the top because now a human can check the work. Let's do the latency budget out loud because almost everyone assumes retrieval is the slow part and the arithmetic settles that argument quickly. Embedding the question takes about 8 milliseconds, searching the index roughly 12 more. Together, that is nothing at all, barely a fifth of a blink. Re-ranking 50 candidates costs around 90 milliseconds, and that is the expensive part of retrieval. Still small and easily worth what it buys you. Then generation 1400 milliseconds. 92% of your latency lives in the model writing the answer, not in anything retrieval did. One stage, nearly everyone skips evaluation. Without it, you are tuning chunk sizes on vibes and calling whatever happens next. An improvement measure two things separately. Did retrieval put the right chunk in the list, and did the answer stay inside the chunks it was actually given? 50 labeled questions is enough to start. So, when should you actually build this thing? Here are three situations, three different answers, and only one of the three is retrieval. If your data is private or it changes every week, build the pipeline. That is the case. Retrieval was made for, and fine tuning handles it badly. If you want a different tone, format, or behavior, that is fine tuning. Retrieval changes what the model knows, it never changes how the model speaks. And if your entire corpus fits comfortably inside the context window, just paste it in. You do not need any of this yet, and that's fine. One line to keep: retrieval doesn't make the model smarter, it makes it accountable, and accountable is the only kind of system you can actually ship.